For this section, we're going to talk about sets. And we have ways of describing collections of objects abstractly. When we're talking about a collection of objects, we're really just talking about these things called sets. And each object in the set is called an element. And so in order to describe these sets, we have a few different ways to represent these sets. One way that we can do this is through listing notation. Sometimes it's even called roster notation. So for example, if I want to talk about the numbers 1 through 5, I could list them in set notation 1, 2, 3, 4, 5. To separate my elements, I use commas. And to show that this is a set, we use these little braces. We could also talk about naming this set. So let's say that I name this set A. We use capital letters. And so if I want to refer to set A, you know that I would be talking about the set that contains the 5 elements that I listed. We could also show that a number is an element of a set, like 2 is an element of our set A, by writing 2, the symbol A. So 2 is an element of A. So this is good if there's just a few elements. Sometimes we want to try and describe larger sets. So let's look at another notation that we have. That's set builder notation. I could actually define the set of the numbers 1 through 5 using set builder notation. I start with the name of the set again. So I'm going to call this set A still. It's going to represent the same set. I'm just going to use a different notation. And to describe this set, I still have curly braces, but I want to talk about a rule or a way to define what goes into my set. So in this case, my set contains a whole bunch of numbers. I'm talking about the numbers 1 through 5. So if I talk about numbers, often we use a variable, say x, to represent numbers. So I can say my set A contains numbers, but I want a rule to say what numbers actually belong in that set. So I'm going to write this bar to mean such that, and then I'm going to state my rule. So my rule is that it's a number between 1 and 5, and I can write that using our inequalities. So I say x, we know that it could be smaller than or equal to 5, but at the same time we want it to be greater than or equal to 1. Now when we write this inequality and we say that x is less than or equal to 5, we want to make sure that we're talking about just the whole number. So we'll include just 1, 2, 3, 4, 5. We don't want it to include fractions or decimals or anything else that could come between those, since when we say numbers, this could be any type of number, including decimals and fractions. So I'm going to write the word and explicitly say that x is a whole number. That way it's very clear what should belong in this set. Now perhaps this isn't as helpful as just listing the set like we did a moment ago, but again, if we get to more larger sets, it might be helpful. Now another notation that we have is called interval notation. Interval notation is really good for when you want to talk about a whole bunch of numbers in a set. In particular, we could think about our number line. So if I'm looking at my number line and I want to talk about all the numbers between, let's say, 1 and 5, not just 1, 2, 3, 4, 5, I'm saying all numbers between 1 and 5. So that would include things like decimals and fractions, like 1.2 or 3.5. So graphically what that would look like, if I want 1 and 5 to be numbers between 1 and 5, I'm talking about everything that sits in here. Since I said between, that makes me think that I don't want to include 1 and 5. So to show not including 1 and 5, I make a little open circle. And now the picture's nice, but what's helpful about interval notation is it can actually show everything between 1 and 5 by just writing a few things down. And that is, I know my end points, so this 1 is an end point, and this 5 is an end point. And so the way to represent this interval that we're talking about is by its endpoints. So the littlest that I am is 1, the largest that I am is 5. Because I'm talking about not including 1 and 5, I actually will put a parentheses. Parentheses means not including endpoints. If I did want to include endpoints, let's look at that set. So if you want to include, in our case, 1 and 5, then I could write a little bracket to show it includes 1. Then I can also do a bracket on the right to say that it includes 1 and 5. So this is includes endpoints. If you're thinking about it in terms of an inequality, the first one that I have here just does not include the 1 and the 5, so we can say that x is all the numbers on the interval, but they have to be smaller than 5 and greater than 1. So as an inequality, those are the values that we're talking about. On the other hand, down here, we're saying that we could be less than, or 1 is less than or equal to x, which is less than or equal to 5. So this little x is sitting in the middle. It has to be smaller than 5, but greater than 1. Sometimes we only want to include one of the endpoints. So if we want to include 1, but not 5, we could write a bracket on the 1 to say that 1 is included, and on the 5 we write a parenthesis to say it's not included. So this bracket says it includes 1. The parenthesis means it does not include that endpoint, which is 5. And in terms of an inequality, we're talking about all the values x that are smaller than 5 but don't equal it, and are greater than, right? It's opening to what's bigger here, which is the x's, greater than or equal to 1.